All right, next tutorial, big ideas for Algebra 2, section 3.4 using the quadratic formula. So we're going to be able to solve quadratic equations, find their zeros, find their roots using the quadratic formula. We're also going to talk about the discriminant, which tells you how many number and type of solutions that there are, and then being able to solve these in a real life problem. So previously we talked about solving quadratic equations either by factoring and setting those roots equal to 0, or by completing the square, where you're moving all the numbers over to one side, taking your b divided by 2 and then squaring it. The next method that we're going to talk about to solve quadratic equations that are written in standard form is called the quadratic formula. So the setup is exactly the same as you would for factoring. You put everything to one side and set it equal to 0, standard form, and then whatever numbers are in your A, B, or your C position are going to be replaced in these values in your quadratic formula. This formula is actually derived by completing the square from just an ax squared plus bx plus c equals 0, and that plus or minus again determines, with it being two solutions, having the positive and the negative version. And then once you plug everything in, you just follow PEMDAS to get it all the way down. So we're going to start with a pretty easy example, x squared plus 3x equals 5, and we're going to solve this using the quadratic formula. So the first thing we need to do is to move all of our terms to one side of the equation and set it equal to 0. So you would subtract that 5 over on both sides. Now you have your A, your B, and your C term. Your A is 1, because it's the number in front of your x squared. Your B is 3. Your C is negative 5. Wherever you see an A, we're going to replace it with the number 1. Wherever you see a B, you're going to replace it with the positive 3. And then wherever you see a C, it's going to be negative 5. So you're just plugging each one of those values in to where that is in your quadratic formula. Then the next thing to do to simplify is just following the PEMDAS. So we're going to do everything inside of our radical symbol first, because there's an invisible parentheses inside all of here. And then exponents would be the first thing that we do. So 3 squared would give you 9. Then when you multiply negative 4 times 1 times negative 5, you get positive 20. So underneath your radical, you have a 9 plus 20, and that's where this 29 is coming from. Then after that simplification, you would then move to multiply. So you would have your 2 times 1 to multiply to get positive 2. Now for your solutions, you will occasionally be allowed to use decimal form. So you can just type both of these expressions into a calculator and approximate to the nearest hundredth, so 2 decimal places. So you would take the square root of 29, add negative 3, then divide by 2 to get your 1.19. And then you would do the opposite, but instead it would be that subtract because of the plus or minus. So you can check this by graphing. Type it in your graphing calculator. It crosses at 2 different points where they are at negative 4.19 for this one over here on the left, and then 1.19 over here on the right. All right, so now looking at a little bit more of a complicated equation that has some bigger numbers, but again, the steps are still exactly the same. So the first thing you need to do is to make sure that everything is all on one side of your equal sign and set equal to the other. So you've got 25x squared minus 20x plus 4. You could also try the factoring method with this one. This is a perfect square trinomial, so you would have your 5x minus 2 times itself or squared it. But just for the purpose of this example, we're going to practice using the quadratic formula. So identifying your A, B, and your C as 25, negative 20, and 4, plugging everything in there to your equation. So wherever you see that B is the negative 20, wherever you see that A is your 25, and the C is 4. Then you would multiply everything on the inside using your exponents first. Negative 20 squared minus these 3 numbers that get multiplied. When you combine those 2 together, you actually get 0 underneath your radical sign. Then 2 times 25 is 50. The square root of 0 is 0, and then whenever you take 20 plus 0 or 20 minus 0, that actually doesn't change. So since we have a 0 underneath our radical, there's actually only going to be one solution. And you would take 20 over 50 divide by 10 to reduce on both sides to get 2/5 as your solution. So you can check that by plugging in the graphing calculator. And again, your vertex is also the coordinate point that is your 0 or your solution to the equation. Okay, now if you have an a as your -1, moving on with the quadratic formula, again, making sure that we're moving everything to one side of the equation, so you would subtract 13. You don't need to do anything different with the quadratic formula. I know in previous methods, if you wanted to try factoring, you would have to pull out the -1, or if you want to complete the square, then you have to divide everything by -1. Even though there's a lot of algebra or simplification involved, there really aren't any steps or anything weird that you need to change about the equation. You just have to have your a, b, and your c in the right spot, and then you simplify all the way down. So nothing's changing there. So when you take 4 squared to get 16, and then 4 times -1 times -13, you combine that with your +16, and you get a -36 underneath your radical. Again, we have talked about complex solutions, so you are no longer going to say that it is no solution because you're going to rewrite this in terms of I. So underneath your radical, you would have the square root of 36 times I. The square root of 36 is 6. And then you would just make sure that you simplify that by dividing everything by 2, since you actually can divide everything by 2. And then you can go ahead and just leave this as your plus or minus whenever you're writing as your answer. Sometimes if you have 2 boxes, you'll have to write those 2 separately. Otherwise, you can use the plus or minus button as your solution. So when you graph that and check it, notice how it is not crossing the x-axis, so there are no real solutions to this equation. The algebraic check is what's showing you how to find the imaginary solutions that use your I. And again, you can determine that by looking at the negative under the square root, which is actually the next thing that we're going to go over. So using the discriminant is everything that is underneath your square root in the quadratic formula. So just the b squared minus 4ac. If you just evaluate or simplify the b squared minus 4ac, you can figure out how many solutions there are. So if you take your b squared minus 4ac and you get a positive number that is greater than 0, so 1/2 is greater than 0, you are going to have 2 x-intercepts and 2 real solutions. The graph will cross twice. If your discriminant does equal 0, which I think we talked back in, what slide was that on? Is it this one or the next one? It's the next one. So this one had a 0 underneath your radical sign. So that does give you 1 solution to the equation. And if you have a negative number underneath your radical, that's where you're going to start pulling out for your I. With a negative underneath the square root, it doesn't cross the x-axis at all, and you're going to have 2 imaginary solutions. So only looking at the discriminant, so you have your equation written in ax squared plus bx plus c. Plugging in just the b squared minus 4ac, you would simplify this down to be 36 minus 40. And since the discriminant is negative, there are going to be no real solutions, but there are 2 imaginary solutions. So you would then plug everything into the whole equation, and then you get your 3 plus or minus I. Okay, for part B, again, still plugging in just the b squared minus 4ac, you would get 36 minus 36, and that gives you 0. So there are 1 solution to that equation, and that solution is 3. X squared minus 6x plus 8 for the last one, part C. Plugging in your A, B, and your C into the discriminant, you get a positive 4. So that means there are 2 real solutions, and those solutions are 2 and 4. All right, let's find a possible pair of integers for our A and C so that that equation gives us those solutions. Then we're going to write that equation. So in order for the equation to have 1 real solution, the determinant or the discriminant has to equal 0. So we're going to figure out what that discriminant is. We do know that we have a -4 in our B position. So that gives us a +16 minus 4 times AC to equal 0. And then what we're going to try and do is get A and C by itself. So we're going to move the +16 over to both sides, then divide by -4. So we know that any two numbers that multiply to equal +4 will give us exactly of a discriminant that equals 0. So you can use 1 and 4. You can use 2 and 2. You can, if you want to get creative and use decimals or fractions, you certainly can. There are an infinite number of, products to get to +4, but if you just keep it to whole numbers, you know that 1 times 4 is 4. So this could be a possible equation where your A is 1, B is still -4 from the start, and your C is the +4, which we determined previous step. You can also check that by plugging in your graphing calculator, just like always, to make sure that the graph crosses the x-axis once, which it does right there at 2. Okay, so kind of to wrap up some things that we've talked about in the entire chapter, the bunch of different methods that we have used for solving quadratic equations. Graphing, just when you want to figure out the use of approximate solutions, where those graphs are going to cross the x-axis or what you're trying to figure out. Using square roots or using algebra. For example, if you have a 4x squared equals 16, that is an appropriate quadratic equation that you can use square roots in algebra to solve. Factoring is always one that I like to check first if it's written in standard form. You try and find your two numbers that multiply together to get A and C, and then the ones that add up to equal your B term. And then factoring is ones where you're getting, somewhat easy solutions or whole numbers or decently small fractions. Completing the square can be used at any time in any type of quadratic equation, but it's easiest if you have an A that equals 1 and then your B that is an even number. It's easy when B is even because remember your first step is to divide by 2, and then quadratic formula works anytime. So sometimes it's nice to practice all of the different types of solving quadratic equations, but remember, whenever you're taking standardized tests, it will not grade you on the method that you choose, but you will be timed, so sometimes using the quickest method can be your best friend when solving some of those problems. So let's finish up with a real life problem when it comes to a juggler and throwing balls up in the air. So leaves the juggler's hand 4 feet above the ground and has an initial vertical velocity of 30 feet per second. The juggler then is going to catch the ball when it falls back at a height of 3. So we need to figure out how long the ball was in the air. So because it's thrown, we're going to use the model of the -16t squared and then plus some number b plus some number h, which is our C position, to find out how long it was in the air when solved, when your h is equal to 3, because that's what the question is asking for, 3 feet. So write the model, then we're going to plug in 3 for our solution, because we're trying to find it where it's caught at 3 feet. We know that it was 30 feet per second, so that number is going in our B position, and the starting position or starting height is 4 feet above the ground. So we're going to plug in 4 into our C. We're going to rewrite this in standard form, so let's move our +3 over to the right. Subtracting 4 minus 3 is 1. So this equation is not easily factorable. You could use complete the square, which is going to result in some fractions. So let's use the quadratic formula just because we know that it always works. So plug in your A, B, and your C into that quadratic formula. Do your 30 squared and then multiply 4 times 16 times 1. You combine those together, 900 plus 64, I think, 964, yep. Then you can just type that into a calculator to get both of your positive and your negative solutions. But we kind of need to put this into a real life situation. The question is asking how long is the ball in the air. It does not make any sense if the ball is in the air a negative amount of seconds. So we're going to eliminate that as a possible solution. and we're going to only accept that it was 1.9 seconds in the air.